Okay, here's a question that they want you to model the function. So they say model this function, the data down below, and write the function. Okay, so I've inputted all the data, and now let me go down here and write the function. So hopefully I can write it, see it. So y1 approximately equal to a log b bracket x1 minus c plus d. There we go. So when you look at that, the dots there, it looks like my function is going through them. So I scroll down here and it tells me what each of the A, B, C's, and D's are. So my function, let me move this over a bit. My function would be y is equal to A. A was 4.6, call it. 4.6 log, and then B is 30. X minus C, O is a negative. Oh, and it's almost 0. I'm just calling that 0. I'm not even putting a number in there. You could, but it's so close to 0, I'll just leave it. And then D is a negative 6.8, call it. So that is my function. So then they say, what if there are 15 offspring? What is their life expectancy? So I need to plug a 15 everywhere I see an X. So let's do that again in decimals. Okay, come on, decimals. Here we go. So it would be 4.6 log bracket 30x minus 6.8. Uh-oh. Minus 6.8. Oh, but I wanted to put a 15 in for x. Times 15. There we go. 5.4. So, and I guess I could have written a function like this. F of x is equal to that stuff. So if I set f of 15, that comes out to 5.4. Then they said, how many offspring do you need to get an average life expectancy of 6.23? So 6.23 is a little bit bigger. And what I could do, and they tell me not on the graph there, is to figure out what that would be. So they're wanting y to be 6.23. So if I look at my graph here, they're wanting me to get up this to 6.23. Oh, that's, so the y value is 6.23. Oh, I'm not there yet. 6, oh, a little too high, 6.235. Oh, right about there. 22.55. So that's how many offspring I would need. 22.55, I think it was. So the life expectancy gets to be 6.23. But in the question, what I wanted you to do is not just look at the graph, but see if you can take that function and solve it. So let's take this function that we have. Let me move the graph out of the way here. So I have this function, y equals 4.6 log of 30x minus 6.8. And they want me to know when it's 6.23. So that's what I'm putting in right there. So 6.23 equals 4.6 log of 30x minus 6.8. First thing I'll do is add 6.8 to each side. Okay, so that'll be 1213.03 is equal to 4.6 log of 30x. Then I divide both sides by 4.6. So 13, need my calculator. 13.03. 13.03 divided by 4.6. I come up with 2.83, call it. 2.83 equals log of 30x. And then this is base 10. So what I'll do is I'll change it to exponential notation. So 10 to the 2.83 is equal to 30x. Yep. And then divide both sides by 30. Okay. So 10 to the 2.83. Good. And then divide that by 30. I get 22.54. 22.54. So with rounding, I'm just a hair off, but on the graph I wasn't exactly 6.23. I think it was 6.231, but it's pretty close. That's how you could do that modeling question with a log function.